So today my topic is perceptron algorithm, and this is the structure of single layer perceptron algorithm, perceptron network. So from this picture you can see that there are single layer in this network, and there are several inputs like x1 x2 up to xm, and there are several weights, and this is the summation part. So what it will do is it will just take the x's and it will multiply with w's and plus bias, so wx plus b, and then it will pass this summation to a function which is called threshold function in case of perceptron algorithm. So here you can see that fx equal to 1 if wx plus b greater than equal to 0, and it is 0 if wx plus b less than 0, and this is the predicted YP. So actually perceptron is an algorithm which is mainly used for binary classifier using this threshold function, but you can also use this for linear regression. So to use it as linear regression, you have to change this as identical function. So what it will do is it will take just fx equal to x. So if you remove this activation function, then it will act as linear regression. And if you take this activation function as a sigmoid function, then it will behave like a logistic regression. So you can see from this list that there are several activation functions and the equations of the activation functions and the examples. So if you take this phi z or fx is the same, so if you take this identical or linear function, it will act as Adalin or linear regression. And if you take the step function or this threshold function, then it will act as a perceptron variant. Like that, there are several activation function. For example, if you take this fx equal to 1 divided by 1 plus e to the power minus x, then it will act as the logistic regression. So here the only difference is the activation function. So if you use fx in different activation function, then this whole network will act as a different algorithm. So you can see that there are several activation functions like logistic, TANH, and ReLU. And nowadays, for multi-layer neural network, this ReLU function is used, which is already discussed in Lab 4 of optimizers. So now let's start from the beginning. So here, suppose here the objective is given four features of a patient, which is age, weight, BMI, and skin thickness, and you have to predict the height, which is YP. So here YP and Y hat is the same. So here the dataset is XI and YI, and XI is the R4, means there are 4 dimensions of the data: age, weight, BMI, and skin thickness, and you have to predict the height, which is a real value. That is why it is regression problem. So first the step is define a loss function. So here the loss function will be mean square error, which is yp minus yi whole square. So yi is the actual class and yp is the predicted height. So yi is the actual height, yp is the predicted height, and you have to sum over all inputs, and yp it will pass through a activation function which is fx here. So yp equal to f of w2xi plus b, and f is the activation function. Then you have to optimize this loss function, which is summation over yi minus yp whole square divided by n, where n is the number of data points. So what is the meaning of the equation? The meaning is the to find the best w's for which this loss function, which is yi minus yp, or you can replace yp as the function of wt plus xi whole square, is minimum for all n or m data points. So as I said, if you use this fx as the identity function, so where identity function means fx equal to x, then it will act as the linear regression. And in case of perceptron, this fx is a threshold function, which is fx equal to 1 if w transpose x plus b greater than equal to 0, or else 0, which is binary classifier. So which is discussed in this example.